Hello, you're welcome once again to New Focus Approach to Mathematics Basic 8. This is the revised edition. And in this lesson, we want to look at angles of elevation and depression. Angles of elevation, angle of depression and elevation. Now let's take them one after the other. Let's take angle of elevation. What is angle of elevation? Let's say you are standing straight, vertically, okay? And take note of this. Anytime you stand straight, your body and then the floor or the ground where you are standing makes an angle of 90 degrees. Take note of that. And so that assumption will be made in the course of our presentation. Your body and the ground makes an angle of 90 degrees, right? That is the first thing. Anytime you stand straight, you have, if your head is not lifted up as this boy's head is lifted up, in your normal sight, you are supposed to view things horizontally. Until you lift up your head and you stand straight, if you don't lift up your head, your normal sight always goes horizontal, and it is horizontal parallel to the ground, okay? Irrespective of where you are standing. The assumption is that your sight is parallel to the ground. Now, because you are looking at an object up, like this boy is trying to look at a plane up there, he has to raise the head or the eye to observe the airplane. Now, there is an angle existing between the normal sight and then the elevated eye. That angle is what we refer to as angle of elevation. Angle of elevation. Angle of elevation. That means the angle is between your normal sight, that's a black line, and the angle that you use to raise your head in order to see the object you are looking up. So you raise your head, so you say elevate, you elevate your head, so that becomes angle of elevation, right? Good. Then another way is this. This time around, you're not lifting up your head up to see something up, or rather you want to depress your eye or your head, bring your head down to look at something down here. Again, your normal sight and then the football or the object you are looking at, or let me put it this way, your normal sight and then the ground is parallel. Assuming that the boy is not bringing the head down, if the head is straight, his sight will be horizontal, okay? Now, because the boy wants to look at the object down there, he has to bring the head down to observe the ball with an angle between his normal sight and then the depressed eye to see the object. The angle created here is what we refer to as angle of depression. So take note of these two words. Elevation, you raise up your head. Depression, you bring your head down. Each of them has horizontal reference point. Okay, so when you go this way, it means you are elevating your head, and you bring it down here, you are doing depression. So in summary, this is what we are looking at. If you stand straight, your normal sight is horizontal like this guy's own. The moment you raise your head up to see the object at the top here, you create the angle of elevation. If you bring your eye down, you create the angle of depression. Now, let's look at how we can use this in solving questions. Let's say, for example, Yao stood 9 meters away from the foot of a vertical pole. Now you can see a pole, vertical pole here. And he stood 9 meters away means that the distance between him and then the pole is 9 meters. Okay, to observe a bird on top of the pole, so you can see a bird here. The angle of elevation from the bird was 60 degrees. That means Yao, with his normal size, should be like this, right? But because he's looking at object at the top, he has to raise the head. That is angle of elevation. And that angle of elevation was given as 60 degrees. Find the distance between the bird and Yao. The distance between the bird and Yao. That means we want to find a distance. Let me call that distance maybe x here. The distance between the bird and Yao. Okay, so how do we do that? We can apply the trigonometric ratio that we've studied, right? Now we know that the distance between the eye of this boy to the point here is the same as the foot to the pole. So I can bring 9 also over here. Now, in reference to right angle triangle, the angle theta here, its opposite is this and its adjacent is 9 and the hypotenuse is x. We know that currently we have to find hypotenuse and we have adjacent. We have to find hypotenuse and we have the adjacent. We don't have opposite, so we can't bring O into it. We want to find hypotenuse and we have adjacent. Which of the SOHCAHTOA, which of the SOHCAHTOA has adjacent and hypotenuse at the same time? Okay, and you can see that is Ka. So we can say cos the angle 60 is equals to Ka adjacent, which is 9, over hypotenuse, which is x. So we want to make x the subject. Now the question said we should consider cos 90 as half. So I can put half in place of cos 90 and then, cos 60, and then simplify it this way. With the help of our simple algebraic work, we can do cross multiplication here. We can have x times 2 times 9, which is 18. And so our x is 18. That means the distance from Yao to the bed is 18 meters. You see, we are able to find the distance between the bed and Yao just the mere fact that we know the angle of elevation and we know the distance from from Yao to the pole. So application of trigonometry, or let's say trig ratios, can help us solve big problems. Let's take another example and see. A boy on top of a building observed a goat. Okay, it's a goat. And I've brought a bed. Okay, the same thing, object. Okay, so a goat or a bed, the same. Building observe a goat on the same horizontal level as the foot of the building. The distance between the boy and the goat is 15 meters and the angle of depression is 53. Draw a diagram to represent the information. So we can see a diagram. Maybe you don't need to draw a building, but you can just draw a line to represent the building and then the boy. Okay, and then the distance between the boy and then the goat or the bed is 15 meters, right? And the boy has a normal sight horizontal, but has to depress the eye to see the object, that is the goat or the bed, with an angle of 53, right? Now, remember we've done what we call alternate angles. So if you look at alternate angles, then this line and that line alternate, or they are parallel, so the angle will alternate here. So 53 can be put here. You get it? Good. Now, because we want to find the height of the building, okay, so the height of the building, including the boy, probably let's take that as our h. Okay. Now, in that case, then this angle will have opposite to the h, and then the adjacent to be the distance here we don't know, but we know the hypotenuse to be 15. So, which SOHCAHTOA can we use? Are we going to use SO, or we use Ka, or we use TOA? So the question is, to know what to use, ask yourself, what do you want? You want to find h, which represent opposite, and you have hypotenuse, you have h. So which one will be the appropriate? That is so. So you can say sine of the 53 is equals to opposite. Opposite is h. Hypotenuse is 15. Thank God they've given us sine 53 to be 4 divided by 5. Then we have our h over 15. We'll do cross multiplication. So 5 times h will give us 5h. And then 15 times that will give us 60. Right. So now we divide both sides by 5 to get our answer for h. So h can be written as 12. Okay, so that is 12 meters is our answer for H. Then we want to find the distance between the goat and the foot of the building. Okay, so let me clean this one. Okay, so the distance, we want to find the whole of the distance, so let me call it distance D from the foot of the building to where the object is, D. And once again, we know here is 53. And so since we want to find D, and D represent the adjacent side of the angle, and we also know our hypotenuse, then it means we need K, so cos 53 should be equal to adjacent of that is D over hypotenuse, which is 15. But unfortunately, we don't have cos 53 given to us in the question, like they gave us the sign, and so it won't be appropriate to use the cos. Since we know our adjacent to be 12, sorry, opposite to be 12, which is the height, we can still go for the sign and say no, we'll rather go for the Pythagoras theorem to find the D, because we know the hypotenuse, we know the opposite side, we want to find D. So instead, we rather go like this. You go and say, okay, hypotenuse squared, 15 squared is equals to 12 squared plus our D squared. That is the easiest way out. So since we don't have calculator to do this, so now we have 225 for this one minus, or is equals to 144 plus D squared. So making D squared the subject, we have 225 minus 144 with group like terms is equals to D squared. So when we subtract, we have 81 is equals to D squared. Okay, so you can say our D squared is equals to 81 means if we take square root to both sides, we have 81. And what is our D? D becomes 9. So 9 meters becomes the answer for D. I'm sure this has been of great help to you. Go ahead, you can revise this, watch it over and over again, and you can solve more questions to master this concept of trig. Thanks so much for watching.